Today we're talking about slope. So let's talk about slope. Slope is the rate of change. And specifically, it is the ratio of a graph's vertical change to its horizontal change, like this. Say if you have a line like this, how fast is it changing vertically compared to how fast it's changing horizontally? So it tells us how steep a linear function is when it's graphed, and it's represented by the letter m. So this little delta sign is something that you may see. It just means change in y over change in x, and you may have heard this as rise over run. And as we said before, it is the ratio of a line's vertical up and down change to its horizontal change, left and right. But really, we're just going to be looking at right change today. There are 4 different kinds of slope: positive, negative, 0, and undefined. So when we're counting slope from the graph, the most important thing to do is identify, first of all, what kind of slope it is. Is it positive? Is it negative? Is it 0? Or is it undefined? Then you can count rise over run. So we're going to move left to right, like we're reading in English. We're going to start at a clean point on the left-hand side of the graph, look for a clean point on the right, count our vertical change, which is going to be a numerator, and then count our horizontal change, which is going to be our denominator. Remember, ratio means fraction, right? Ratio is a fancy word for fraction. So we're just making a fraction, okay? If 2 points aren't given, you need to choose 2 clean points, meaning that they cross at nice, even grid lines that you can count. Fractions must be reduced. So if I have 2 over 1, it's going to be just 2. If I have negative 6 over 4, well, that's negative 3 over 2. And if you struggle reducing fractions, remember, Desmos can help. So step 1, identify, is this positive, negative, 0, or undefined? This one is positive, so my slope better be positive when I find it. Okay, I'm going to go from this point to this point and see what I get. So 1, 2, 3, 4. I have 4 on the top over 1, 2, 3, 4, 5, 6. 4 over 6. Can that fraction be reduced? Well, if I go from here to here, let's see what I get. 1, 2, 1, 2, 3, 2 over 3. What about from here to here? 1, 2, 1, 2, 3, 2 over 3. So this is going to be a consistent ratio. It doesn't matter how big the triangle is that I make. All the triangles will be the same going along this graph, and they will all be 2 over 3. And so m is equal to 2 over 3 here. M is equal to 2 over 3. All right, let's try the one on the right. I'm going to move from this point to this point. Is the slope positive or negative? Step 1, identify whether it's positive, negative, 0, or undefined. It's negative. So I know that whatever m is equal to, it better be negative. I'm going to go down 1, 2, 3, 4. Well, since I went down 4, I'm going to make that negative. And the bottom number will always be positive. 1, 2, 3, 4, 5, 6, 7, 8 to the right. Negative 4 over 8. Can that be reduced? Let's try some, let's draw some other slopes. Let me see if I can get another color here. Let's do orange. Let's go from this point to this point. 1, 2 down, 1, 2, 3, 4 over, negative 2 over 4. 1, 2 down, 1, 2, 3, 4, negative 2 over 4. Can that be reduced? Last one. How about from this point to this point? Negative 1 over 2. Negative 1 over 2. And you can see that all these triangles will have the same ratio, but the slope is equal to negative 1 over 2. And these are all equivalent fractions to that. I'm hoping that you can see these little triangles are all the same. And now we have our special cases. So if we have a horizontal line, let's say this is our x-axis and this is our line. A horizontal line we can remember with the acronym HOI. It's a horizontal line. With a slope of 0. And the equation looks like y equals a number. Or you can think of it as crosses y-axis. It crosses the y-axis. In contrast, our vertical line can be remembered with the acronym VUX. It's a vertical line with an undefined slope. And it looks like x equals a number is the equation of the line, or you can think of it as crossing the x-axis. So let's take a look at a couple on Desmos and see what we're talking about. Let's start with our zero slope. We have a couple different examples of this. We have a nice horizontal horizon. It even has the word horizon is in horizontal, right? How about this nice flat line? That's horizontal. It should look like y equals a number. HOI. HOI. Y equals a number. There you go. Another horizon. This one has a setting sun. Anything else that, here's one more. It crosses the y-axis. It crosses the y-axis. There you go. There are our 8 cards of horizontal. So what have we got here? A vertical line. A vertical line. VUX. How about this tree here? It has an undefined slope. It's a vertical line. Undefined slope. And we can remember x equals a number, or we can think of it as crossing the x-axis. It crosses the x-axis. And you can remember an undefined slope as, is this a hill that you would want to go down? No way. And these are your undefined slopes. I hope that was helpful. Thanks for watching.